Welcome to 5-Minute Serverless. In this episode, we talk about testing serverless applications using Hexagonal Architecture. As we saw in the previous episode, when writing a serverless function, we need to think about configuration, technical workflow, business logic, and integration risks. We need good architecture to handle them all. One of the great ways to do so is applying hexagonal architecture, or ports and adapters, to our serverless functions. Hexagonal architecture allows an application to equally be driven by users, programs, automated test or batch scripts, and to be developed and tested in isolation from its eventual runtime devices and databases. Let's see how does that applies to our serverless functions. Alex and his team use AWS, and they ended up with the following structure. Function business logic exposes few ports. For example, one for an incoming event, one for permanent storage, and one for notifications. They have two adapters for the event that triggers a function, one for the real AWS Lambda trigger and another one for local testing. They have several adapters for permanent storage and notifications, for example, DynamoDB table adapter and in-memory adapter. Before we continue, let's go back to our serverless testing pyramid and see how this architecture affects all tiers. Unit tests are the same, but easier to write. Alex can simply use a mock as an adapter to test the function business layer in isolation. Integration tests benefit a lot from hexagonal architecture. They were able to test integrations that they own thoroughly. Third-party integrations are simulated with other adapters. As Alex and his team were building a backend for the app, the UI test tier was not relevant. However, they can use serverless to improve these tests, too. UI tests are expensive and slow because they run in the browser. Serverless is cheap, and it scales fast. Alex and his team can run a browser in AWS Lambda to gain cheap parallelization and make the UI tests cheaper and faster. Let's see the code example. We'll build a simple Books API with an API gateway, Lambda, and DynamoDB table. Before we begin, make sure you have the following prerequisites. You also need a basic knowledge of node.js and TypeScript. Start by creating a new folder and navigating to it using your terminal. We'll call it Testing Example. You can initialize an AWS SAM project the same way we did in the first episode. Run the following command from your new folder using your terminal. This command will create a new AWS SAM project with a Hello World function written in TypeScript. Open template YAML file in your favorite code editor and replace Hello World function with the following getBooks function. Add an API event trigger with get method and books path. Also, modify the outputs to output the API URL. Serverless REST API is an implicit API created by our getBooks function. SAM will deploy the prod stage by default. Then add a DynamoDB table to the resources section of your template file. Books table can look similar to the following CloudFormation resource. Before we can write the code, pass a table name in an environment variable, and add a policy that allows your getBooks function to read data from the database. To do so, use the DynamoDB read policy, SAM policy template. The infrastructure is ready. Let's add code. Start with the Books database repository. Create the common folder in the source folder. Then create the BooksDB repository (TS) file in that folder. This file represents the Books database repository that will communicate with DynamoDB and should have the following content. I think you should avoid scanning the DynamoDB table whenever you can, but we'll use scan in this video just to demonstrate how to test a function. Update the main TS file in the lib folder of getBooks function to have the following content. Finally, update the Lambda TS file to import the following modules and types. And update handler function to have the following content. Build and deploy this project to confirm that everything works as expected. To do so, run the commands you see on your screen. When the deployment finishes, SAM will output our API URL. If you visit the URL with books path in the end, it should return an empty array. Now that our API is working, let's switch to testing. Open the main tests TS file of your getBooks function and replace the content with the following code. For unit tests, you can create a jest mock with the same interface and pass it to the getBooks function. For integrations tests, create a local database adapter because we do not need to test each function against the DynamoDB table. With a local database, integration tests are simple. Pass a local database repository instead of BooksDB repository, and check the results. Run the following command from your terminal to run your tests. Integration tests for Books database repository are even more important, and slightly more complicated because we create the DynamoDB table at the beginning and destroy it at the end of the test suite. We can create a DynamoDB table in the Before All section using the following code. Just keep in mind that creating can take some time, so increase the timeout to 60 seconds. Destroy the table after the test suite is done with the following code. The full example is available on the following GitHub repository. Thanks for watching the first episode of 5 Minutes Serverless. Feel free to send me feedback or questions on Twitter.